Hi. All right, here we go. Chapter 8 is going to take us into management, but a different piece of it, the management of production and factories. Our learning objectives are the following. Describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. Describe the evolution from production to operations management. Operations management is a much larger function. Identify various production processes and describe techniques that improve productivity, including computer-aided design, known as CAD, and computer-aided manufacturing, known as CAM, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. Number 4, describe operations management planning issues, including facility location, facility layout, materials requirement planning, purchasing, and just-in-time inventory control. And finally, we're going to take a look at something that you all may be very interested in, may be able to make use of in your careers, PERT and Gantt charts. They're used for planning. By 1979, nearly 20 million people worked in manufacturing. Approximately 12.75 million people worked in manufacturing in 2018. The value of products made in the US reached a record high, even though we had less people working in manufacturing. We've talked a lot about where those people went. Some of those jobs went overseas to countries where labor is cheaper, and a lot of those jobs went away because of technology, robots, computers, which is the next one on the list, technology and automation. Unlike their predecessors, modern factory robots can safely work side by side with humans. Do you think that manufacturing someday could be driven entirely by automated labor? Guaranteed. You can take a look at Amazon as a good example. Amazon fulfillment centers now use robots to pick all of the products that go into an order. The human beings just pack them up in the box. Manufacturers and service organizations become more competitive. As things get tougher in the world with worldwide production, people have to get more competitive, come up with new ideas. They're fighting things like competition from China and other countries. Innovation used to be primarily in the United States. Now, not so much. Now it's a US activity, but it's not just the US, it's happening around the world. How can US businesses maintain a competitive edge? Focusing on customers, number one. Because remember, as more and more companies make things, those things become less unique. So what becomes important in getting customers is providing customer service. Production management and operations management. What's the difference? Well, production is simply the creation of finished goods and services. Production management refers to the activities managers do to keep those things moving. Operations management includes production management type operations, but also things like inventory management, quality control, production scheduling, follow-up services, a lot more into operations management than just the production of the product. In the service sector, there's also operations management. In my career in the private sector, I worked for mostly professional services firms. And the key that everybody was talking about was something called exceeding the client's expectations, meaning we know what the clients are looking for. In order for us to become really successful, we have to beat that. We have to give them more than what they're expecting. Operations management allows companies to turn their ideas into actual goods and services. Operations management for services is all about enriching the customer experience. Like I just said, exceeding expectations. Hotels, for instance, have responded to the needs of business travelers with in-room internet access, and a lot of times now you don't have to pay extra for it, and other kinds of office-style support, as well as stored information about the preferences of frequent guests. They always have an office room down on the ground floor with computers that are available, printers, and internet access. All right, so here is the production process in 3 pieces. The first piece, inputs, land, capital, labor, and entrepreneurship. Those are the 4 factors of production. And then include on top of that knowledge. Under production control, we have planning, routing, scheduling, dispatching, and follow-up or quality control, QC. And finally, the outputs, obviously goods and services and ideas. I love this chart. I kind of like Krispy Kreme donuts. I try to stay away from them. But look at that. This is number of items made in a minute. Now, obviously, this isn't a Krispy Kreme retail store. This is a Krispy Kreme factory. But 5,200 donuts every minute. That's a lot of donuts. Chips Ahoy cookies, 4,000 a minute. Lifesavers, 100 rolls in a minute. This is huge production. The need to improve production techniques and cut costs. Cutting costs is usually the number one thing in a manufacturing company. You're looking, how do we make things better, faster, cheaper? Goal is high quality goods and services in response to customer demand. The US is more competitive because of CAD and CAM, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. Now, under mass customization, somebody who really took that to a huge degree was Michael Dell. Before Dell Computers was around, you basically bought your computer from a box. Whatever was in it was in it. Yeah, you could go to a computer store, a small computer store, and they would put together what you wanted. But for the most part, people were buying just off-the-rack kind of computers. Michael Dell came along and said, come out to my website, and I'll let you customize your computer, and I'll get it to you in 7 to 10 days. That was unheard of. That's mass customization. Computer-aided design and manufacturing has changed production techniques. Obviously, being able to use a computer to design a product. I worked for an architectural firm for a long time. They used computer-aided design to do the drawings. And what it allowed them to do was not only to do the drawings, but they could do what if. If I put this here, what happens here? Okay, let me take that out. And what happens if I do it here? So on the computer screen, they could move things around before they came to the final drawing. 3D modeling techniques, computer-aided manufacturing gave us 3D printers. We could actually print a 3D product. Flexible manufacturing. Machines can do multiple tasks. If you look at a factory floor, you'll see that there are machines all over the floor. If you can get one machine to do more than one thing, you're reducing the number of pieces of equipment you have to have on the floor. Lean manufacturing, if you think about what lean means to us from a physical standpoint, it means losing fat, right? Lean bodies. Well, lean in manufacturing is the same thing. Less human effort, less space, less investment in equipment, less engineering time, greater savings. Robotics were great for mass customization. They improved productivity, but they also got rid of people's jobs. So one of the things that companies need to do as they go more towards robotics and computerization and using overall more technology is to think about the people that are being replaced. Amazon has been having commercials on streaming TV for quite a while now, talking about how they're taking people out of the fulfillment centers and sending them to school and getting them a technical education so they can come back to the company and they can work on the robots, they can work on computers, they can write programs. 3D printing has become a big problem for the police in that 3D printers are now being used to make guns and make guns out of things not metal. So they're much harder to find. Facility location. Facility location is a major decision for manufacturers and other companies. Why? Well, because the decision involves taking into account the workers that I need, the supplies that I need, the customers I'm looking for. The closer I am to the customers, the less I have to pay in shipping costs. Facility location in the future. Information technology makes telecommuting a major trend. Reduced need for companies to locate near sources of labor. Something we don't think much about, if you look at the floor of a manufacturing plant, the layout of the plant is very important. Where they put things determines how efficiently the process is going to run. You could have an assembly line layout, and we're familiar with that. We've seen that since Henry Ford. There's a modular layout where teams of workers produce complex units of the final product. There's a fixed position layout where all the workers go to one place. So here's our standard assembly line, right? We put tires on the car, and then we put the body on the truck, and so forth. Then there's this process layout, frequently used in operations that serve different customers, different needs. So we have stations, and not all the stations are going to be used by all the products. Maybe we're going to cut the product, and it doesn't need to be stamped or deburred. Deburring typically is with things that are made out of metal, because when you stamp metal, you get rough edges. So you have to take it to a station that has like sandpaper, where you can smooth the edges so they don't catch on anything. And then maybe bending, but maybe not. Maybe we just cut it, assemble it, pack it, and ship it. Sounds like an IKEA piece of furniture right there, doesn't it? Cut, assembly, pack, and ship. Here's a module layout. So we have different machines in this circle. Some equipment gets used, some doesn't, depends on the product, but it moves from one station to the next. Fixed position. Building a house is a perfect fixed position layout example. All the contractors, all the workers have to go to one lot to build the house. So everybody's working there. MRP and ERP. So materials requirement planning uses sales forecasts to make sure needed parts and materials are available at the right time and place. So ERP takes it one step further. Single integrated software program that uses a single database for everything. Orders, payment, scheduling. It reduces inventories, reduces ordering and processing costs, and obviously, because it's more efficient, you get better customer service. Just-in-time inventory is something that the Japanese gave us in the 70s. Just-in-time inventory control says, why should we have a big warehouse that costs us a ton of money and that we fill up with inventory and then we move that stuff into production as we need it? Why don't we use smaller amounts of inventory and have the inventory produced by suppliers close at hand? So we keep maybe a week's worth of inventory instead of a month or 6 months worth of inventory, cuts our cost, and our suppliers get it to us faster. Quality should be part of operations management planning, and that's where we come into Six Sigma, statistical quality control, and we talk about ISO 9001 and ISO 14001. The International Organization of Standardization, ISO, sets standards for production. In other words, they'll say they may have a standard that says for every 1,000 pieces that are made, there can be no more than 5 that didn't come out correct and have to go into waste. PERT and Gantt charts. PERT and Gantt charts are really important for planning and operations. We're going to take a look at them right now. So here's a PERT chart. What does it say? Well, we've got the start here. In 1 week's time, the star and the song are chosen for the music video. Now we move off 4 weeks from here, the set gets designed for the music video. In 2 weeks, set materials are purchased. 6 weeks later, the set's constructed. 1 week after that, we're ready for rehearsal for the set. Now, on the other side of the coin, we're looking for costumes. So 3 weeks after the star and song is chosen, the costumes are designed. 1 week later, the dancers are measured, and then we have to order the costumes. That's 4 weeks. And then the dancers were ready for rehearsal again. And in here, the dancers are selected. In 2 weeks, they're choreographed for 4. And then 4 weeks after that, they're ready for rehearsal. So what does the PERT chart do? The PERT chart helps us to understand that if, for instance, there's a supply chain issue and it's not 2 weeks to get the materials, it's 4 weeks. That pushes all of this 2 weeks back. So maybe we had a rehearsal hall that was scheduled here. Maybe in 2 weeks, the schedule hall isn't available anymore. So now we need to look for someplace else. So it allows you to plan ahead based on how well these milestones are being met. Then comes the Gantt chart. The Gantt chart tells us how things are going to flow in the production of this, for instance, here for a doll. So machine heads molded, completed work. There's still a bit of work to be done before the end of week 3, but in the meantime, machine B is working. Machine C has to start here in week 4 in order to have the clothing sewn in week 5, assembly in week 6, and week 7 we're all ready to go. So again, we can look at this and say, well, if machine A is slow and it's taken up till the middle of week 4 instead of the middle of week 3, we're now a week behind. So you can look at it and say, well, how can we move this and cut time a little bit so we can still make it in 7 weeks, but take a little less time for the remaining work. And that's it for Chapter 8. If you have any questions, please get in touch with me. I've been having Zoom meetings with your classmates. I've had a couple of phone calls. So I'm here for you if you need the help.